Module 8, Structural Inspection Part 1. The ASHI standard of practice covers the structural components in Section 3. The inspector shall inspect structural components including the foundation and framing. And we should describe the methods used to inspect underfloor crawl spaces and attics. All they mean by that is, did you enter it? Did you look at it from the hatch, or did you not look at it at all because it was inaccessible? We describe the foundation, the floor structure, the wall structure, the ceiling structure, and the roof structure. As the home inspector, you are not required to provide engineering or architectural services or analysis, nor are you required to offer an opinion about the adequacy of structural systems and components. I'm sure you'll recall that we had a pretty extensive discussion regarding these types of exclusions back in the inspection process in Module 3. But just to give you another example, say you're doing a home inspection. Your client asks if they can put their grand piano right in the middle of the living room floor. Will that floor be strong enough? Well, just the way houses are framed, I'm sure it would easily handle the weight of that piano. But nevertheless, you're not required to offer an opinion about that. Let's say, and I think I used this example before, let's say they want to know if they can add a second floor to this one-story home. You don't have to answer that question. These types of questions are best answered by general contractors, architects, or engineers. Now, if you have a background in which you feel like you could safely answer that question or accurately answer that question, then feel free. But you don't have to do it. You are not required to enter underfloor crawl space areas that have less than 24 inches of vertical clearance between components and the ground, or that have an access opening smaller than 16 by 24 inches. So the standards of practice are trying to give you a limitation on how far you have to go with a very tight crawl space. Now, this doesn't mean that you shouldn't enter these types of spaces if you feel that you can. If you are a slender individual and you could get through a hatch of that space or smaller, and you can do the army crawl and move around in a crawl space with only 18 inches of clearance, then you really ought to do that for customer service. But if you just don't feel like you can fit into that type of space, or it makes you really claustrophobic, the standard of practice has you covered. We're also not required to traverse attic load-bearing components that are concealed by insulation or other materials. In other words, you don't have to walk in an attic where you can't see the tops of the joists or the bottom cords of the trusses, however that attic's framed. From Section 13, General Exclusions, the inspector is not required to determine the strength of systems and components. So again, there's some redundancy built in. And the inspector is not required to enter areas that, in your professional judgment, might be dangerous to you or other persons, or might damage the property or its systems and components. So not only have they given you a limitation on the size of a crawl space and crawl space hatch that you have to enter, although you can go into a smaller space if you want to, they've also allowed you to use your own judgment as to whether or not you should even go in a crawl space or an attic because you think it could be hazardous. Again, I used this example earlier. You open the crawl space hatch. You can see that it's full of water. You're under no obligation to go into that crawl space. You would simply document it on the report. Literally, you would say that the crawl space appeared to be full of water or had a foot of water or whatever you want to say at the time of inspection and the crawl space was not entered. And we're not required to enter underfloor crawl spaces or attics that are not readily accessible. We looked at this definition earlier, but as a reminder, ASHI defines readily accessible as being available for visual inspection without requiring moving of personal property, dismantling, destructive measures, or any actions that will likely involve risk to persons or property. So if a crawl space hatch is covered by wall-to-wall carpeting, yes, I've actually seen that, you are under no obligation to pull back the carpeting. If the attic hatch is caulked, screwed, and painted in place, you are under no obligation to enter that attic. You don't have to open that hatch. Of course, any of these circumstances should be documented on the report. When we design and build houses, we do have a goal. The structural goal is to safely transfer the combined weight of the occupants, the furnishings, and the house itself to hopefully stable ground. Stable means solid, undisturbed ground capable of supporting a heavy structure. Most of the time when we have foundation issues, it's because some part of the foundation was placed over less than stable ground, causing the foundation to shift or settle. This diagram shows a bunch of terminology that you really need to know. This is basic framing terminology. You'll need to know this to pass any test that you take, and you need to use this terminology on your inspection reports. Some commonly confused terminology that I'd like to point out, because I've seen this done incorrectly on many inspection reports. When we say joists, we're talking about horizontal pieces that support floors and ceilings. Columns are vertical. Columns are posts, and they provide support for joists and beams. I've seen many inspection reports where an inspector is trying to talk about the column and he or she says that the joist was rotted at the bottom. So we need to make sure we're using the correct terminology. If you need to, take a few moments and study this diagram over and make sure you know all of these terms. Everything on the Earth is subject to gravity, and gravity pulls everything down towards the Earth. When you have a gable roof, the forces in red, the tendency of everything to try to move down and then cause the sidewalls to spread out, those forces are counteracted by collar ties. The idea of placing a collar tie in an attic is to make a triangle, because a triangle is a very stable figure. You may recall from geometry squares, rectangles, and triangles. Well, a rectangle is not quite as stable as a triangle, because a triangle is fastened only at 3 points. It's a stable type of structure. Now, the rest of the forces in blue in this diagram are resisted by footings, again, hopefully on stable ground. If one or more areas of the ground underneath these footings are not stable, there's going to be some foundation movement. When you get up into the attic of a home, you'll see the rough framing. That's either going to be rafters, sometimes known as stick-built, because carpenters take individual pieces of wood when they frame the home. So it's either rafters or trusses. Trusses are prefabricated, pre-manufactured components. So the trusses are assembled at a factory and brought out as a single piece on a truck. And then each truss is placed with a small crane on top of the house. So these are prefabricated, usually with the gussets as you see at the yellow arrow. The gussets are usually metal. Rafters can be field modified, that means changed later on by qualified framing contractors, which is just a fancy way of saying carpenters. Trusses can never be field modified, so after the truss is put into position, that's it. A carpenter is not allowed to decide to start removing parts of the truss. When the roof is framed with rafters, in other words, stick-built, we need to come up with some solution to stabilize the structure or to at least reduce the span to help minimize sagging. So in the top diagram, the use of collar ties both serves to help keep the walls from spreading out and to help stiffen up the structure because we're reducing the span. By making that triangle, we have cut the span down considerably. And that helps to resist the tendency of the rafters to sag, especially under wind and snow load. A second way to do that is through the use of purlins, as you see in the second diagram. Purlins are attached to the rafters, and then they are brought over so that the downward forces are transferred into a bearing wall. Now, bearing walls bring forces all the way down eventually to the foundation. A third way to do this is with knee walls. And as you can see here, the knee walls are simply attached to the rafters on the top end and ceiling joists at the bottom end. So they're not overbearing walls, and sometimes what happens is a cosmetic crack will develop in a ceiling right underneath a knee wall. So I say cosmetic because it's usually nothing really to worry about. It's just kind of an annoying that the crack is always going to be there. You could patch it. It'll probably come back. And it's simply because the ceiling deflects slightly downward at a time that there's some extra loading placed on the roof, whether that's from wind or snow. If you're inspecting this home, you're up in an attic space and you should wonder where the collar ties are. Now, I've put the blue question mark here because it's a limited visual inspection. You can't see what's underneath the drywall, so you don't really know how the framing has been done. You could simply check the window and check the baseboard heater and so forth and be done with it. But really, you know this is not framed with trusses because if they had trusses, they've taken out a lot of the components of the trusses, and that would be a huge structural issue. So if it's stick framed, which it must be, there's no collar ties, there's no purlins, there's no knee wall, so you really ought to wonder about that. And you also got to wonder, what are the structural ramifications on the rest of the home? This is the exterior of that same home. So the window up in the gable is the same window that you saw when you were up in that finished attic space. The weight of the roof structure and the shingles are pushing the structure down, causing the sidewalls to try to spread out. But at least in this case, that movement is being resisted by the wings of the house on either side. So it's hard to say if whoever did this work just got lucky or if they really thought about it and realized that those side wings would help keep the house from spreading out. But there is actually another issue. By removing the collar ties, they could get an excess amount of movement or sagging from the rafters. So chances are you probably ought to say something. You probably ought to recommend further evaluation by a carpenter. These are trusses. Trusses are engineered, manufactured structural components. The key word here is engineered. And that's why these cannot be changed in the field without the guidance of a structural engineer. Let's compare engineered components to dimensional lumber. Engineered framing components are factory fabricated using various combinations of solid wood, steel fasteners, high-grade adhesives, wood chips, or thinly cut wood strips. Engineered lumber cannot be field modified unless directed by a structural engineer. That's it. There are no exceptions to that rule. When we talk about dimensional lumber, we're talking about solid wood sticks, sometimes known as sawn lumber or stick lumber. In other words, 2x4s, 2x12s, and 4x4s, and so forth. Stick lumber can be modified by a qualified carpenter because carpenters put the sticks together to build a structure. But here's how engineered lumber works. Engineers can design structural members such as trusses, certain types of beams, and certain types of joists to provide maximum strength using minimal material. Now, when I say certain types of beams and joists, I'm not talking about solid wood beams or solid wood joists. I'm talking about engineered beams and joists, and I'll show you the difference as we move through this module. So, engineers design these members to provide maximum strength using minimal material. That leaves no room for error either from untrained contractors or the homeowner, because every piece of wood at a truss is critical to the overall strength of the truss, because all that extra material has already been eliminated. There's nothing left to safely take out. Everything I've underlined with yellow is an important term that you need both for your tests and your inspection reports. So the bottom of the truss is known as the bottom chord. The top of a truss, those are the top chords on either side. Everything in between all those sticks are known as webs or web members. And everything is attached to each other with gusset plates. The gusset plates are either metal or occasionally plywood. Again, trusses can never be field modified. Now, when we say field modified, that means not changed simply by the decision of the carpenter or the homeowner. If trusses are going to be field modified, it can only be done under the direction of a licensed structural engineer. Engineered manufactured structural members, including trusses, laminated beams, and either open web joists or eye joists, can never be cut, altered, or field modified unless directed by a licensed structural engineer. I cannot emphasize that point enough. Anytime you see any type of engineered structural member that looks like it's been changed in the field, whether it's been cut or pieces have been removed, further evaluation by a licensed structural engineer should always be recommended. Always. For example, you go up in this attic. These are trusses. You can see all the webs have been cut. You have no choice. In fact, your decision is very easy because you have no decision to make. You simply recommend further evaluation by a licensed structural engineer, and that's the end of that. Subflooring is a flat material laid directly on top of a joist. Finished flooring is placed on top of the subflooring. That could be carpeting, some kind of sheet good like a vinyl floor or a ceramic tile, or hardwood flooring. Subflooring is a structural component, and it has to be strong enough to hold the weight of appliances, furniture, people, as well as the finished flooring. These are the typical subflooring materials that have been used in residential construction over the years. The two photos on the right illustrate the use of boards for subflooring. Boards are often placed perpendicular to the joist, but they were occasionally placed diagonally to the joist. Starting in the 1950s and through the 1970s, we used plywood for subflooring almost exclusively. In the late 1970s and early 1980s, we started to use a lot of oriented strand board, or OSB. Today, OSB is the predominant subflooring material, although plywood is still commonly used. Joists distribute the weight of furniture, people, and materials in floors and ceilings to bearing walls, foundation walls, or beams. Joists may either be solid wood, otherwise known as dimensional or stick lumber, or they may be engineered lumber. Joists have very specific requirements for notching or holds, depending on whether or not it's solid wood or if it's engineered lumber. Here are the various joist types that have been used in residential construction throughout the years. In the upper left, older homes used to use solid logs for floor joists. That's basically like having a bunch of beams. Needless to say, that's a very, very solid home. In the upper right, solid wood joists used for 150 years or more. The two photos at the bottom are both engineered components, engineered materials, open web joists, which really look like trusses. They essentially are trusses and I-joists. I-joists are growing in use every year. I-joists are the fastest growing type of joist in the United States right now. Field modification requirements for these same types of joist. Well, if you do an ancient home where they're using logs for joists, you can just use your best judgment because it's really no building code or any guidelines that really cover that. Solid wood joists can be field modified by carpenters. And open web joists or I-joists, those are both engineered products, so they can only be field modified under the direction of a licensed structural engineer. So drilling and matching for solid wood joists. These are the parameters. If notches are going to be made in the joist, whether that's for piping or something else, notches are allowed in the top or bottom of the joist, but only to a maximum of 1/6 of the total joist depth. And notches are not allowed in the middle third of the span. So the notches should only be toward either end. If someone wants to drill a hole in a joist, the maximum size of the hole should be no more than 1/3 of the joist depth. At the end of a joist, the notch can be up to 1/4 of a joist depth. So it can be a little bigger if it's at the end of the joist. Now, let's talk a little bit about the actual size of joists. When we talk about a piece of wood being a 2x12, well, it's not really 2 inches by 12 inches. Maybe you already knew this. Maybe you didn't. But a 2x12 is really, in actual inches, it's 1.5 inches by about 11 1/4. So with an actual dimension, when we say a notch in a 2x12 only being 1/6 of the joist depth, in real dimensions, that's a little less than 2 inches. So these notches are not very big. For our 2x10, which is really 1.5 inches by 9 1/4 inches, the actual size of that notch can be no bigger than 1.5 inches. In this home, the joists have been badly overnotched to allow the installation of a plumbing waistline. Probably the plumber did that. Doesn't really matter who did it though. As we just saw, 1/6 the total depth of the joist is the maximum notch allowed. In the first joist that you can see, that notch is about half of the depth of the joist. And we're not supposed to notch at all in the middle third of the span, which is hard to tell from the photo. But this might be the middle third of the total span. So literally, if a joist is 9 feet long, you're not supposed to be notching the middle 3 feet. All you can do when you see something like this is recommend further evaluation by a qualified carpenter. Now, does this mean that this house is going to collapse because the structure is too weak? Probably not. Probably is not a good word to use in a home inspection report. I don't think you want to tell your client, well, the floors will probably not fail with these notches. And obviously, this home's been here for a while and nothing has gone wrong. But if somebody did put a lot of weight in these areas, like that grand piano we talked about earlier, they might have a problem. So you absolutely have to recommend further evaluation. It doesn't matter how long it's been like this. Now this is a very old home. These joists were overnotched and at the center of the span, so you have two things going. The notches are too big and they did it in the center of the span. But that was done many, many, many years ago. And obviously, nothing has gone wrong for probably 50 or 60 years. Yes, you should probably still report this. Again, we don't know how your client plans to use the home. Maybe they do something differently that no one else has ever done and they cause the joist to crack. Another issue is the parameters we're teaching you here. Those are industry accepted parameters about how you can notch joists. We're not making it up. So if you chose to ignore these notches on these joists on this particular home inspection, if you were to rationalize it, well, it's been there for many years, I don't think there's going to be any problem. Well, okay, probably there isn't any problem. But if your client sells the house 2 or 3 years from now, another home inspector comes through to do this inspection, and they're going to use the same parameters, well, they're certainly going to write it up. Guess who's going to get that call? You are, because you said nothing about it. And then you're going to have a lot of explaining to do. And you could possibly set yourself up into some kind of a claims situation. So don't over-rationalize it. Just report it, recommend a carpenter, and let things go from there. These notches are at the end of a joist span. And they're less than 1/4 of the total depth of the joist, so they're just fine. And that brings us to engineered joists, which can never be field modified. Now, remember when I say field modified, I'm talking about changes these components without the direction of a structural engineer. It's literally what we mean. So it doesn't matter if a homeowner does it, or a carpenter, or the heating guy, or the plumber. Engineered joists cannot be changed except under the direct supervision of a licensed structural engineer. So anytime I say field modified, that means that an engineer is not involved. So again, engineered joists can never be field modified under any circumstances. So everything you're looking at in this diagram, except at the top, is an engineered component. So at the top, it's a solid wood joist. Everything else is engineered. The wood truss, also known as an open web joist, the I-joist, the plywood joist, because that's really a series of pieces of glued lumber, even the metal bar joist, that is considered to be an engineered joist. And laminated veneer beams and parallel strand beams are all engineered lumber. So none of these can be field modified except the piece at the top, the dimensional lumber. Due to physics, not all the wood in a solid joist is needed to transfer loads to the beams and bearing walls. These extra wood fibers add very little strength, and they can be effectively eliminated. This concept allows joists and beams to be engineered and manufactured using less material than solid wood joists. That's the whole concept behind engineered lumber. These are open web floor joists. There really are trusses. These are hard to look at. When you're crawling through a crawl space or even in a basement, there's an awful lot of pieces to look at. And if even one of these pieces, if any one of the web pieces have been removed, that's a defect you should be finding and reporting and recommending further evaluation by structural engineers. So you really have to take your time with these. I absolutely hate looking at these because it's just very time-consuming. Then we have wood I-joists, which are a lot easier to look at. Wood I-joists have some very special requirements which we're going to cover. First of all, I-joist flange sizes and materials vary as needed. So if you look at the inset photo, you can see flanges that are made from laminated veneer lumber, timber strand, or solid sawn, in other words, solid wood. But I-joists have an OSB web that's just 3/8 of an inch thick. They're all the same that way. Here's how they work. As an I-joist deflects under load, and any joist deflects under load. Deflection is simply the tendency of the wood structural member to bend down a little bit as some weight is placed on it. So solid wood joists deflect, open web joists deflect, I-joists deflect anytime a load is placed on them. So as an I-joist deflects under the load, the top flange is in compression. Just picture that joist bending down a little bit. On the top flange, the wood fibers right at the area of the load are sort of pressed together. And at the bottom flange, well, the bottom flange is stretched out a little bit as it's pushed down. So as it stretches out, the wood fibers are in tension. Between the flanges, we have the 3/8 inch OSB web. The wood fibers in between the flanges have much less compression or tension, and less strength is needed. That's why we can get away with the web being only 3/8 of an inch thick. I-joists are much stronger and stiffer than solid wood joists, and they're lighter weight for the same span. In many cases, I-joists can be laid out on 24-inch centers instead of the typical 16-inch centers. Of course, that means the subfloor has to be a little bit thicker. The webs are much easier to cut for the trades. This diagram is taken from APA EWS, Performance Rated I-joists. That's available in the reference library on the ICA website, and I strongly recommend that you download it and look it over. It is, I want to say, something like 20 pages. APA, by the way, is the American Plywood Association, so this guide is the Bible for what you can and cannot do with an I-joist. I'm just going to give you the highlights right here. First of all, smaller holes are allowed at the ends, not larger holes. Larger holes need to be towards the center. Exactly where those larger holes can be comes from Table 5 in APA EWS. There should be a minimum of 6 inches between the bearing point of the joist. In other words, the bearing point is where the joist is bearing on something else, whether that's a foundation wall or a column. So it should be a minimum of 6 inches between the bearing point and the first hole. Any holes that are grouped together, and I'm not sure why you would group them together, but grouped holes are essentially the same as one large hole that could contain all the small holes. There should be a minimum between holes of twice the diameter of the larger hole. Pre-scored knockouts should be used whenever possible. And what that means is many I-joists come with knockouts pre-scored. That's illustrated in the diagram, those little circles with dotted lines. Those are indicating the pre-scored knockouts. Actually, many joists today actually have the holes pre-cut for use by the trades. Very, very important. On an I-joist, because the top and bottom flanks are so critical, they can never ever be cut, notched, or modified in any way. If you see that on inspection, it's time to recommend the licensed structural engineer. Holes should be centered vertically, and the distance from the end support or from the point of bearing should be as per Table 5. There should be a minimum of 1/8 inch of web material from the edge of any large hole to the flanges. Yes, we can actually sometimes cut holes that large in an I-joist. That would be at the center of the span. And the reason you need 1/8 of an inch of web material is really to make sure that you're not hitting the flanges in any way. For the most part, holes that are 1.5 inches diameter or less can be placed almost anywhere. They still need the 2 times diameter spacing, and there is a limit of 3 maximum sized holes per span. So I realize that's a lot of information, but study it over. Get familiar with I-joists. Download the APA EWS guide. Go through it. And the more you read it, the more familiar with it you'll get to be. If a lot of the I-joists are used in houses in your area, you'll start to get used to seeing them. So here's a sample piece of an I-joist. You can see the pre-scored knockout hole. That's for the trades to use as needed for pipes or electrical wiring or whatever. And here's an I-joist with the holes pre-cut ready to go for the trade. So those holes are big enough for piping, for ductwork, and whatever else might need to go through there. You can see at the left end of that joist, it clearly says no cuts, because they want everyone to stay away from the bearing point. Notice also right above where it says no cuts, it says this side up. Not all I-joists will say that, but if they do, they're dead serious. Sometimes the joists are made with a little bit of camber in them, or a little bit of preset curvature to them. And that is to help resist the tendency of the I-joist to deflect and then form a low spot. So if the I-joist says this side up, they're dead serious about it. If you were ever to see an I-joist with the this side up pointing down, that would be a major defect you would definitely have to report. This I-joist has a field cord hole. That's okay. For whatever reason, someone knocked out one of the pre-scored knockouts. That won't hurt anything. And you can see a couple of the other knockouts still in place. Well, here the top flange of this I-joist has been cut not once, but twice. You have no decision to make here. It's very easy. You must recommend further evaluation by a licensed structural engineer, always. By the way, if you're in an urban area where they issue a lot of building permits, you would get excellent backup from any building department. So if you were to write this up in an inspection report and your client went to the current owner and said, "Hey, my home inspector said the I-joist has been damaged and you have to get a licensed structural engineer," well, if that current owner went down to that town's building department and said, "Well, you know what? This home inspector said I have to get a licensed structural engineer because my flanges on my I-joist have been cut," the building department would say, "Hey, thanks for letting us know. Now you're going to need a building permit, and you're going to have to submit a drawing stamped and sealed by a licensed structural engineer." I guarantee you that's what's going to happen. So you will get excellent support from anybody else when you write this up. The thin web of an I-joist does not handle concentrated loads from columns or bearing walls very well. And that makes sense. It's only 3/8 of an inch OSB. So it's not surprising that it would tend to crush or roll. So to resist that tendency, we use squash blocks. And squash blocks are usually just 2x4s that are cut about 1/16 of an inch longer than the depth of the I-joist. And they transfer the vertical loads from bearing walls above, around the I-joist, down to the solid framing or the foundation below. On this home that's under construction, it's very easy to see the squash blocks. These are 2x6s, and sometimes they use 2x4s. These are 2x6s, which is even better. They're cut slightly taller than the I-joist itself, so that when exterior bearing wall is placed across there, all the weight from that bearing wall will be transferred, not through the joist, especially not through that 3/8 of an inch web of the joist, but through the squash blocks instead and down to that sill plate below. These are all examples of squash blocks that have been placed under heavy loads to transfer the weight of those loads above, around the I-joist, and to the framing below. Squash blocks, in some areas, are known as cripple blocks. Wherever the ends of an I-joist don't have to have a type of hanger because they're bearing on a wall or a beam, and where they don't need squash blocks because there's no heavy load above, well, in those situations, they should have rimboard or blocking panels just to resist the tendency of the thin I-joist from rolling or shifting from side to side. So, as you see here, this was done correctly. If you ever need to go I-joist to I-joist, common sense tells us that 3/8 inch thick OSB is not going to hold any fasteners very well. So in that situation, we have to use web stiffeners, sometimes known as backing blocks, so that when you go I-joist to I-joist, the nails or the structurally rated screws that you're using have something to grip into besides just the 3/8 inch web. Bearing stiffeners are also used with joist hangers. Joist hangers for I-joist can be a little different than joist hangers for solid wood because of the different configuration of the material. Once again, we have the top flange of an I-joist cut. In the I-joist industry, this cut is so common it has a name. It's known as a bucket cut. When you see the bucket cut, you recommend further evaluation by a licensed structural engineer. This entire section of I-joist has just been hacked away. And then someone's tried to box it out with 2x4s. Well, you can't treat this like a solid 2x12. So you know what you have to do now. You have to recommend further evaluation by a licensed structural engineer. Here's a whole series of I-joists in which the holes were placed closer than 2 times the diameter of the largest hole. There might be 7, 8, 9 joists like this. Yeah, it's probably the plumber's fault. Doesn't matter who did it though. You have to write it up. Over the years, there have been several different types of joists and supports used in residential construction. I've asterisked the 3 most common for you, the ones that you're going to see all the time. Starting at the upper left, the joist bearing directly on a wooden sill plate, and then moving down to the bottom center, joist supported at beams with joist hangers, and then the bottom right, where the joists bear directly on beams. That is by far the most common type of joist support that you'll see on home inspections. But all of these other diagrams have been done at some point in time at different houses. I've never actually seen, at the upper right, I've never actually seen joist supported quite that way, although I guess it was done in some homes. At the center left, the mortise and tendon joint, that's very common on homes that are 100 years old or even older. That's considered to be a very desirable connection. It's not done anymore simply because we don't have the old growth wood. And that's a very time-consuming connection. At the lower left, where our floor joist is embedded in a masonry wall, we tend not to do that anymore because that has a tendency to cause rot to develop at the end of the joist. All holes in a joist hanger need proper nails, all of them. Now, you don't have to check every individual joist hanger in a home, but you should spot check them. And if you see a joist hanger missing 1 or more nails, you should check a couple more. Perhaps it's a trend. Absolutely, I've been in home inspections where I noticed that they skipped the top 2 nails in every joist hanger. It's not extremely difficult to correct that after the fact, but someone is going to have to come in and place the nails. And, by the way, there are proper nails to be used for joist hangers, not roofing nails and not regular wire nails. There are actually specific joist hanger nails that are supposed to be used. They usually have a little mark on the head. You can see that in this photo. So, joist end bearing on wood. We want at least 1.5 inches of that joist to be bearing on wood. That would be on a wooden sill plate as an example. For an I-joist, should be about 1.75 inches bearing on wood. Now, you don't have to measure this stuff, just eyeball it. For a solid wood joist bearing on concrete or masonry, which is that older style construction, that really isn't done anymore, at least it shouldn't be, but we'd want at least 3 inches of bearing on that concrete or masonry. And again, that's just in case we get a little rot or softness in the wood. That's to give us a little bit extra beef there, basically. And I-joist, because that's a newer technology, we just really shouldn't be putting those directly in concrete or masonry. The joist overlap at any beam, whether it's a steel beam or wood beam, they should overlap by at least 3 inches. And I-joist minimum support of the beam should be about 3.5 inches. Next, we have bearing walls and partition walls. Bearing walls provide support to joists, beams, or other bearing walls above, and transfer the loads safely down to structural components below. So bearing walls cannot be removed without providing another means of support. So if someone wants to pull out a bearing wall because they want to make a room larger, they can possibly do that, but something's going to have to replace the bearing wall. So we have to add beams and columns as an example. On the other hand, partition walls are just fill-in walls just to form rooms, basically. They can be removed without any impact, similar to an office cubicle partition. So if your client starts asking you about walls in a house, they might say, "Hey, can we take this wall out between these bedrooms and make it a larger room?" Maybe, maybe not. Someone's going to have to determine if it's a bearing wall or a partition wall. Now again, depending on your background, perhaps you'll know just by looking at the framing of a home, you'll know quickly whether it's a bearing wall or a partition wall. And if you feel comfortable and answer that question, go ahead. But if you're not sure, you don't have to answer that question, and your client can bring in a general contractor to determine if the wall is a bearing wall or a partition wall. And on an existing home, wall frame in general is not going to be visible. Now, the only place you might see wall framing is down in a basement where sometimes part of it's finished and part of it's unfinished for the utility room. And when you go into the utility room, you'll see the back of the wall frame. But for the most part, wall framing is not going to be visible in an existing home. Now, the walls you're looking at here, some of those are bearing walls, and some of them are just partition walls. When we talk about beams, we're talking about a significant structural member that carries joists and/or bearing walls and distributes the weight to columns, to the foundation, or occasionally to other walls. Beams should never be cut or notched anywhere because they are major structural components. So it doesn't matter if they're solid wood beams, tripled joist made into a beam, or a steel beam. Doesn't matter. They should never be cut or notched. At beam pockets in foundation walls and over columns, beams should never be shimmed with wood or clay brick material because it may rot, crush, or deteriorate, causing the beam to shift. Again, notches or holes are not allowed in beams. If you should see holes or notches in a wooden beam, recommend further evaluation by a qualified carpenter. If you see holes or notches made in any other type of beam, recommend further evaluation by a licensed structural engineer. So we know that beams can never be notched. Here you go. This beam has been notched. Because it's a wooden beam, it's actually a doubled or tripled up joist being used for a beam, and that's okay except that it's been notched. So because it's wooden, you'll recommend further evaluation by a framing contractor, or in other words, a carpenter. Beams may be solid wood, steel, occasionally aluminum, or engineered as is this one. LVL stands for laminated veneer lumber. This beam looks good. No one has notched it anywhere. No one's put holes through it. That's exactly what we want to see. You can see actually that this is an older home and they have replaced the beam because laminated veneer lumber did not exist 80 years ago. When a foundation wall is poured, when we're talking about a concrete foundation wall, when that's poured, a beam pocket is formed so that later on, when they complete the foundation framing, they can place that beam in the pocket. Now, it's common to use some shims to get that beam to exactly the right height because it'd be difficult to pour the bottom of that beam pocket to the exact height that's needed within a 1/16 of an inch. Steel shims can be used, that's fine, but we should never see wood or pieces of brick, such as this. If you look carefully, you can see how that wood is crushing. It's not crushed really badly at this point, and perhaps it'll never shift anymore, but that's exactly why we don't want to use wood as a shim. And we don't want to use any kind of clay brick because that can crack and deteriorate. So here's a beam bearing and a bunch of old wood scraps. That's not good. When you see stuff like this, simply recommend further evaluation by a carpenter. Working our way down through the house, structurally speaking, we have columns and piers. Piers are just short columns usually used in crawl spaces. Both need to be within a few degrees of plumb. In other words, true vertical. Columns or piers, neither one should be bearing directly on dirt, although sometimes this is hard to find, especially in a basement with a poured concrete floor. So remember, it's a limited visual inspection. Do the best you can. It's usually easier to figure that out in a crawl space with a dirt floor than it is in a basement. Materials used for columns and piers over the years include steel for both piers and columns in either basements or crawl spaces, wood for pier and columns in either basements or crawl spaces, masonry piers, whether made from brick or block, typically just in crawl spaces, and poured concrete piers, typically just in crawl spaces. At the upper left, the very common steel column that you see all the time in homes built today. At the upper right, an older wooden poster column. You always want to be careful to check the bottom of any wooden column for rotting. At the lower left and lower right, those are both crawl spaces with either brick piers or poured concrete piers. In the crawl space at the left, it looks like there has been some added steel screw jacks. Looks like they did a very nice job. You could dig around in the stone a little bit around the screw jacks and see if there's any type of foundation that's been poured, any type of footing. But even regardless of that, you'll certainly want to mention that on the report that it looks like some structural modifications have been made to give your client a chance to check with the current owner. But really, it looks like whoever did that did a very nice job. As I said, always check the base of a wood column or pier for rotting, especially in basements that you think may have been damp, and especially in crawl spaces. But even in basements that seem very dry, sometimes you start probing around and you get surprised at the severity of the rot at the bottom of a wood column, even though the basement seems very dry. So never assume. Always make sure you check it and probe around a little bit. And steel columns are not impervious to moisture damage either. Always check carefully at the base of any steel column for rust. This one is almost completely rusted through, so it has very little strength left in it. For something like this, recommend further evaluation by a carpenter. Down in this crawl space, this is exactly what we saw, just the way it was. And it's probably been like this for many, many years. A dry-laid masonry pier. Dry-laid means no mortar was used. The bricks were just stacked up. Now, I'm sure at the time they did it, they had that little concrete chunk which looks like it's bearing on a piece of wood. And who knows what's underneath that? I can't remember at this point. But there really wasn't a proper foot, I do know that. And I'm sure at the time they set it all up, it was pretty well vertical. But over time, it's shifted. It's nowhere near plumb. This really isn't that big of a deal, truthfully. Obviously, you want to report it. It looks terrible in the picture, but you'll just recommend review by a carpenter. Repairs like this, the biggest expense is going to be for the labor because some poor carpenter has to get down in this crawl space, temporarily shore up the house, remove this mess, add a proper post, remove the temporary shores. Just going to be a major pain for him. And so the cost is going to come from all the labor, not from the material. When we refer to checking, we're talking about the shrinkage cracks that develop in old columns and beams, which were really big timbers. And that cracking or checking is simply caused by the wood drying out and shrinking, so it's very common, and it's usually acceptable. We have made it down to the foundation. You should view as much of the foundation as possible. You usually can't see too much around the exterior, but still take a look at every area that is exposed on the exterior. And when you get to the interior, hopefully not too much of it is covered by finishes. Foundations are absolutely affected by underlying soil types. Unstable foundations often create issues that show up, but other places in the house. In fact, almost all of the time when you find cracking in walls or cracking in brick, it's almost always due to shifting or sinking of the foundation. Vertical cracks in concrete foundation walls are often not structural issues. Sometimes they are, but often they are not. A lot of times are just from typical shrinkage, but they certainly could allow seepage to get into the crawl space or basement. On the other hand, horizontal cracks often indicate lateral movement and are considered to be problematic cracks. And anytime you see a horizontal crack, you should recommend further evaluation. There are three basic foundation types. The basement or cellar. Most of the foundation walls are accessible from a space under the house that is tall enough to walk in. That's what makes it a basement. Of course, many basements are finished to create additional living space. And with a finished basement, you are not going to be able to see a lot of the foundation. The next is the crawl space. Most of the foundation walls are accessible from an unfinished space under the house that's no more than a few feet tall. So generally, you can see all the foundation walls in a crawl space, provided the crawl space is tall enough where you can at least crawl around in there. And the third type is the slab on grade. No access underneath the house at all because the house is just sitting on the ground, essentially. There are three substyles to the slab on grade: supported, floating, and monolithic. So this is a supported slab on grade. In this type, the slab is supported by the foundation. Then, we have the floating slab on grade, where the foundation wall is poured and it's taller than the level of the slab. So the slab itself is bearing directly on stable ground below. There is usually a layer of gravel placed before the slab is poured. The third type of slab on grade is the monolithic pour, in which the slab and the perimeter footing are all poured at the same time. This type of construction is common in garages, in many climates, and occasionally for houses in certain warm weather climates where the ground never freezes. By the way, you don't have to identify which type of slab that you have when you're doing a home inspection. You don't have to report that as a monolithic or a floating slab. You're not going to know. You will know, however, if there is no basement or crawl space. So on your report, you would simply say foundation type was a slab on grade. And that's all you have to say. Foundation materials vary. Concrete is by far the most common, especially the most common used today. Over the years, we've used different types of masonry for a foundation, whether that's concrete block, brick, stone, or even terracotta, which is sort of a clay material. Some foundations are actually piers, sometimes known as pier and beam construction. This is common in wet areas or marshy areas, or right along rivers or lakes. And we've sometimes used the so-called permanent wood foundation using pressure-treated wood. This one's supposed to be rot-resistant. It's claimed to last over 100 years. We haven't had any of those that long yet, so who knows if they really will last 100 years. I might sound kind of skeptical, but that's only because of my practical experience with pressure-treated wood, in which I've seen pressure-treated wood actually rot after just 20 years. So maybe the foundation will make it 100 years, maybe it won't. So here are some of your foundation material types illustrated. Concrete at the upper left, by far the most common used today. A lot of homes were built with concrete block and continue to be built with concrete block foundations. Only in older homes will you find stone or brick foundations. Some more foundation types. Pier and beam foundations of the upper two photos. Again, commonly used in wetlands or in wet areas such as along streams or rivers that may overflow in the spring. The two bottom photos show pressure-treated wood foundations. If you've never seen one of these, it's pretty odd when you get into the crawl space area. It almost looks like they didn't remove the forming from when they poured the concrete foundation. But in fact, that wood is meant to stay there. And hopefully it lasts at least 100 years. Foundations are always caused by issues with the soil, whether it's because it's bearing on unstable soil or because the home has been built on clay and within clay. Clay causes a lot of trouble for foundations because it shrinks a lot when it dries out. And it expands a lot when it gets wet. So when you have a period of a lot of rainfall in an area with a lot of clay, that clay can expand to the point where it puts a lot of pressure on the foundation walls. In this diagram, you can see where most of the house was placed on sandy soil with good bearing capacity, but part of it was on silty soil, which allowed the foundation to move and crack. In a perfect world, we'd build every building on bedrock, but that's not practical. So we build a lot of houses on clay, because there is a lot of clay in the United States, all over the United States. Certainly, there's areas of the Southwest or Southeast where there's not too much clay, but all throughout the Midwest, up into the New England states, and even in the Northwest as far as I know, there is a lot of clay in that area too. So we spend a lot of time building homes on clay because to remove all the clay, you'd have to excavate so deep, it just wouldn't make it worth it. So we do the best we can. The worst possible thing you can build a home on would be organic material, because that is still currently rotting, and that will absolutely shift. You don't typically see the footing on a home inspection, but they're very critical to the stability of a house. So footings should be on stable soil. You can see where the footing is on the inset diagram. That is at the very bottom of the home's structure. So in the main photo, this is a footing that's just been poured, hasn't cured yet. But after the concrete cures, as long as that footing is on stable ground, you can see that the footing is wider than the foundation wall, which would only be about 8 or 10 inches thick. So that footing provides ample bearing for the foundation. In cold weather climates where, in the winter months, the ground will freeze, there is always an accepted frost line. And that's listed in all the local building codes. Anytime a home is built, the footings are required to be placed below that accepted frost line. Now, the reason I say it's an accepted frost line is because it's determined based on historical data. However, very often in a real winter situation, when temperatures are below zero for 2 or 3 weeks at a time, frost may actually go below the accepted frost line to the real frost line, at least real for that winter. Nevertheless, the building codes simply require the footings to be placed below those accepted frost lines. Now, anytime a footing was placed above the frost line, it simply means that when the ground freezes, because of moisture, the ground is going to expand, and it could cause the footings to move up and down. And that can cause all sorts of structural problems in a house. So again, the frost line is defined as the typical deepest point to which the ground freezes over in any given winter season. And building frost lines are established in local building codes based on experience and historical data. And the footings have to be at least as deep as the frost line. Really, going a foot or two below the accepted frost line is better practice just in case you have those extended winter conditions where it's below zero for 2 or 3 weeks at a time, and the frost gets driven below the given frost line. Just as an example, in different parts of the country, the required footing depths based on the accepted frost lines. In Seattle, you only have to go down 12 inches. In Chicago, you have to go down 3.5 feet minimum. In Fargo, North Dakota, you have to go down at least 54 inches. If you want to know what the frost lines are in your area, simply check with one or more of your local building departments. So if houses are moving up and down, most common is probably because of frost heave. And that's where one or more areas of the home were built on footings that are above the accepted frost lines. Adherence freezing, or adfreezing, that sometimes happens in areas with a lot of clay, clay being a material that pretty well sticks to the foundation. And if the clay freezes, it sometimes lifts the foundation. Whenever we have expansive soils, again, clay, that can cause the ground to move up and down, especially every time the clay dries and then gets wet again. And whenever we have a home with a high water table, that can certainly cause the home to move around a little bit. We can try to control that high water table through the use of sump pumps and sump pits, but pumps can only do so much. So when you're actually inspecting structural components, first of all, there aren't that many serious structural issues in houses, although this is always going to be one of your client's biggest concerns. Very, very, very seldom is there any type of major structural collapse in a home. The most serious structural issues are usually foundation related. So as you move through the house, structural clues such as diagonal wall cracks or binding doors usually point to the foundation. If you're doing the top-down inspection that we're teaching, you'll often not see the interior of the foundation until the end. So, if your client is with you, be careful with any comments you make until you see the condition of the foundation. When you're inspecting the structural components, you always have 4 options on what to say on the report. First, you can say nothing, because it appears good in every possible way. There's nothing wrong with it. Or, you could recommend something be monitored, such as minor cracking on a foundation wall, especially when it's mostly vertical. You can simply suggest that the client keep an eye on it. The third thing to do is recommend checking with the current owner. That's a good idea when something looks like it might have been repaired, as an example. So you direct your client to check with the current owner and find out when it was repaired, why it was repaired, when it was done, if there was any warranties, and so forth. The fourth option is to recommend further evaluation. Now you have 3 subcategories of that. You can recommend further evaluation by a qualified framing contractor or carpenter, same thing, or further evaluation by a qualified foundation contractor, or you could recommend further evaluation by a licensed structural engineer. So, recommending that an item be monitored by your client is appropriate when you're sure that an item is not a structural problem, such as minor wall cracking. What you would say in your report is that you recommend monitoring of the crack over time. And if it appears to change, contact a qualified contractor for review. You should never ever state on your report that something appears to be stable or that it is structurally stable unless you are a licensed structural engineer. And very, very few home inspectors are licensed structural engineers, so we should never be saying that. Here is an example of minor cracking in a ranch-style home. It's got a full basement. It's built in the 50s. That cracking sure doesn't appear to be recent. You've been all through the home. There is no other big issue. This is a good example of when you can recommend that the client monitor the crack. I doubt seriously that it ever changes. I've got the question mark here because you don't really have to say anything about this. This is up to you. Is this dangerous? No. Is it functioning properly? Yeah, it is. The foundation is doing its job. So a lot of inspectors would simply recommend the client monitor this crack. And the reason you would say monitor the crack as opposed to saying nothing, it's because if the client moves in and sees this crack and doesn't remember you talking about it, and it's not documented anywhere on the report, well, they might get concerned about it. And they might call you back to ask a question, or they might bring in somebody else to look at it. So that's why it's best to probably just address it in the report up front. Now, when it comes to recommend that your clients check with the current owner, this is appropriate when something is likely okay, but you don't know the history of it, such as repairs to a structural component. The report language you use, you would say recommend checking with the current owner to find out who performed the repair to the joist, as an example, and when it was done, and if there are any transferable warranties. If the client can't check with the current owner because it's a foreclosed home or it's an estate sale, then they can get it reviewed by a qualified contractor. So here's a good example of joists that were overnotched near the end. Now they're not overnotched all that much. Remember, at the end of the joist, you can go a quarter depth of the notch. This is probably closer to a third of the depth. Someone has put a little strapping in there, a little bit of wood they've strapped in somehow. Is that okay or not? Yeah, probably. But you can recommend the client check with the current owner. And if they're concerned about it or if there is no owner, they can have a carpenter come in and take a look at it. So again, we have the question mark because this one is largely up to you as to whether or not you want to say anything. Now, if you have experience in carpentry, you might be thinking that that patch is a little bit light. And it probably is. But having said that, there's no real serious issues here either. Here is an example of a repair that's been made where the mortar has been patched after some pretty obvious movement. Somehow, the bricks have moved down and away. Now, a picture's always out of context. Perhaps on the home inspection it would be clearer as to what actually happened here. But in any case, we can see the mortar is still intact. Those black lines you see there along the bricks, those are shadow lines. That's not a gap. The mortar's all nice and solid. It's still intact. So this is another example of a good time to recommend that your client check with the current owner and find out what's going on here. As a reminder on who you should be recommending, defects with dimensional lumber, such as cut solid wood joists or missing joist hangers, you can recommend further evaluation by a qualified framing contractor, which is just a fancy way of saying carpenter. Foundation issues, and we haven't talked too much about this, but foundation issues can often be referred to a qualified foundation repair contractor. That's their specialty. So foundations that are cracked or shifting or moving around, that is their specialty. Engineered product defects, such as trusses or I-joists or anything else unusual that you see in the home, you should refer that to a licensed structural engineer. So here's a cracked joist. Probably been like that for many years. Nevertheless, you recommend further evaluation by a qualified framing contractor by a carpenter. Here, this home has had the rough frame of trusses, and somebody, probably the homeowner, wanted to add an attic ladder. And they've cut through the bottom cords of the trusses to install this attic ladder. We can't touch the bottom cords of trusses, so you have to recommend further evaluation by a licensed structural engineer. As a home inspector, even if you're a licensed home inspector in your state, you don't typically try to determine the cause of a structural defect or how to correct it. But you do need to know how to sort out what is probably typical cracking from problematic cracking and be able to confidently identify when a structural issue appears to be from current movement, which would cause you to recommend further evaluation by either a structural engineer or a foundation contractor. One of the more difficult parts of a home inspection is deciding when cracking and settling is typical or it's a current issue. If you get lucky, from a home inspector's point of view, if you get lucky, The settlement or cracking will be extreme enough for you to easily decide to recommend further evaluation, such as something like this collapsing wall. Now, absolutely, this might have been like this for many years. In fact, I'd say it probably has been like this for many years. But it might also be getting slowly worse. In any case, this is severe enough that you have to recommend further evaluation by either an engineer or a foundation contractor. And no one's going to argue with you on that. This is pretty severe. Now, you definitely don't want to practice engineering. Any cracking that's not typical, in your opinion, and that's an important point, if you're not sure about it, then that's your opinion. If you don't feel sure about it, you should direct it to a qualified contractor or licensed structural engineer for further review. Don't ever feel pressured into telling your client to simply monitor a defect if your gut feeling is that it requires further evaluation by an engineer or contractor. If you don't feel right about it, then recommend somebody else. You shouldn't incur a whole bunch of additional liability for just a lousy inspection fee. That's not our role. So if you don't like it, recommend that somebody else look at it and be done with it. Now, as far as identifying when cracking is typical, most vertical cracks in concrete foundations are from normal shrinkage and settlement, and many are typical. Typical cracks in finishes are usually only cosmetic annoyances that are difficult to prevent. Even if they're patched, they come back. Almost every older home and newer homes will have some settlement or seasonal cracking in both the foundation and the walls, both of the interior and the exterior. This is a good example of typical seasonal cracking, usually caused by expansion and contraction of the underlying wood framing. You can tell your client to simply monitor this cracking. It might get tighter and wider as it moves through the seasons because the underlying wood framing expands a bit, especially in the more humid summer months. And in a winter climate with the heating season, the wood framing tends to dry out. And it shrinks a little bit, so then the crack gets a little bit tighter. Your client can patch this crack, but it's a good chance that the crack will return. Knee walls, which are typical in Cape Cod-style houses, often cause typical cracking in ceilings directly underneath. And that's simply from wind and rain and snow, or even seasonal expansion causing movement in the rafters and subsequent moving up and down of that knee wall. This ceiling is directly underneath the knee wall above in a Cape Cod-style home. The crack has been patched. It's not a bad job of patching it, but even so, because of the repeated movement, you can still see a somewhat raised area. At least it's not cracked through at this point. However, you should tell your client that this will always move. It may possibly crack again, just so they know about it and also so they don't think that it's a structural issue later on if the cracking reoccurs. At this point, really, it'd be best just to leave this alone because that small raised area is not at all that objectionable. And chances are, if your client tried to patch it again, they'll probably just make it worse. This is typical shrinkage cracking. Shrinkage cracking usually occurs soon after the concrete wall is poured. The reason we feel it's typical is because it's pretty close to being vertical. It doesn't get wider anywhere. It's the same width all the way up and down. And it's pretty much a hairline variety. So this is a good example of a crack. You can tell your client to monitor it. If any seepage occurs, it can be epoxy grouted or urethane grouted to stop the seepage. But if no seepage ever occurs, it will probably be like this for another 100 years. This is an example of epoxy grouting that's been done in a foundation simply to stop seepage. Epoxy grouting is hardly ever done in residential as a structural repair. It's simply to stop seepage. When you're doing a home inspection, how do you decide when cracking might be problematic? In other words, a sign of a structural problem. Well, first of all, anytime you have multiple cracks or pairs of cracks, especially when those appear to come from the same area or the same point, that's almost always a sign of some type of structural problem. Horizontal cracks are almost always due to structural issues. They're caused by generally lateral movement or lateral thrusting of expansive soils. But they can also be caused by other issues. Differential movement or displacement, whether that's horizontal or vertical, in other words, when you have different areas of a foundation wall moving independently of each other. We'll show you pictures of that in a little bit. Anytime the crack gets wider from the point of origin, that's not a good sign. And vertical cracks. I did say earlier a lot of times vertical cracks were typical, but when they're exceptionally large, they're no longer typical. And here you can see that we have a pair of cracks. Actually, the one crack dies off in a mortar joint, and the other one extends up by itself, but even so, the pairs of cracks, and also look at the mortar joints and the brick. That's a good example of differential movement. The mortar joints no longer line up. That's because of movement in the foundation. These are problematic cracks. And you would definitely recommend further evaluation either by a foundation contractor or a licensed structural engineer, really depending on what you see at the foundation level. This is horizontal cracking. It's almost always a problem, and you should always report it. There's some type of movement going on, probably in the soil, along the foundation, some type of lateral movement that's causing this to essentially buckle in. Here is a great example of differential movement. Anytime you see this type of movement, you'll see it show up somewhere else in the house, either around the corner or even on the other side of the home. But you can never have cracking and movement to this degree without it also showing up somewhere else. This crack gets a lot wider as it moves up, to the point where you've got some pretty significant cracking right underneath the window. This type of cracking also will show up somewhere else in the house. Whether it's around the corner or in a longer ranch-style home, it might even show up on the other side of the house. And while this is a vertical crack, it's pretty big. And it's coming off the corner of a window. Possibly that's due to some lintel problem or some other issue. But definitely recommend further evaluation. This is a good example now of a crack, and you're not 100% sure what caused it. It comes off the top of a window. It goes up, but it doesn't go down, so it's probably not a foundation issue. Is it a problem with the lintel, which would make it an issue for a masonry contractor? It's hard to say. So, if you're not sure about something like this, then go ahead and recommend a licensed structural engineer. The structural inspection starts at the exterior of the home while you're doing other exterior issues. Absolutely, you're looking at grading and siding and trim and windows, but you're also inspecting the structure. You want to view the exterior of the house from a distance before getting up real close to the home, because you want to be able to see if the home is leaning or if the roof is sagging. So visually, you always start at the top and work down, just as everything else we do in this course. Top down, always. Check walls for plumb and square as you walk around the corner of the house. So we view this house from a distance first before we get up too close to the home. And you scan the house visually from the top down. So you're looking for structural defects as well as for peeling paint and missing trim and siding defects. So you're kind of doing a bunch of things at once. That sounds kind of overwhelming right now, probably, but after you get some experience as a home inspector, you'll find that it actually goes pretty smoothly as long as you work the inspection system. As you move around the house, and this is an easy house to look at because it sits on a lot of land, you can check walls for plumb and to make sure they're not bowing out as you walk around a corner. So literally, as you walk around the corner of the house, you turn your head 90 degrees to look at the plane of the next wall of the house. So you're looking to see if the plane is bowing out because that wall should be nice and flat. You want to see if it's bowing out at all because you go all the way around to the side of the house and you look at it that side dead on. Sometimes you won't notice that the wall is bowing out. That's why we suggest you do it this way. So, you view the house from a distance. Standing across the street looking at this home, it's very easy to see that there has been some significant settling. The home appears to be dropping down on the right side of the home. Right side as we're looking at it. Look at the limestone eyebrows over the windows. They're no longer square to the house or even square to the windows. In fact, the window shade in the second floor window isn't even square in the opening. That may not have anything to do with the house, but it's certainly kind of curious. I also don't know whether the fallen railing has anything to do with the settling. But certainly, before you've even entered this home, you should be thinking about recommending either a licensed structural engineer, as we said in the text box, or possibly a foundation contractor. Potential structural defects that you see on the exterior often can be matched up with corresponding movement that you'll see when you get to the interior of the home. Sometimes, though, the exterior defects are severe enough that no match to the interior is necessary, causing you to simply recommend review without having to see any part of the interior. Here's a good example of a structural defect that actually might make you already feel you need to recommend somebody. But it can definitely be matched up to the interior. So we have this cracked slab, clearly with some differential settlement. This home is a slab on grade, so there's no foundation wall that we can see. This is it right here. But you can see the crack is very big. And one side of the slab has moved out about 1/8 of an inch with respect to the other side. When we go inside the house, you see that and you know that the crack is all the way through the slab. This slab is moving around. Even if this had been covered by carpeting, you could probably feel the crack through the carpet. You would know where to look based on what you'd seen outside and literally just feel around through the carpet. So you have to report this and recommend further evaluation, even if you didn't feel the crack through the carpet. And the way it actually was on this home, wide open, easy to see the crack, we recommended further review by a licensed structural engineer. This shows a pretty classic case of step cracking along with some differential settlement. As you can see, by the yellow line where the corner of the home has dropped down and away from the rest of the home. This type of crack will also show up around the corner. And when you get into the interior of this home does have a basement, and you'll be able to see the cracked foundation as well. The fact that the downspout just dumps into a splash block is probably not helping the situation. But in any case, this is probably a pretty good repair job for a foundation contractor, so that is who you would recommend for further review, a foundation contractor. These two photos show the same window, and you can see in the right side photo the cracking at the bottom of the window. And even in that photo, you can see how the cracking is getting wider as it moves up. And you can also see where the mortar to the right of the window appears to be previously patched. You can see some sealant next to the window tearing open. And when you look at the upper corner of the window, which you see in the left photo, you can see how much movement we have by the time you get from one corner of the window up to the other corner. That's some very significant movement. Absolutely, you'll recommend further review. I guarantee you this is caused by the foundation, and you will definitely see this type of cracking somewhere else in the house. This is an example of some movement in a home, and someone tried to patch the resulting cracks in the brick. But they didn't correct the underlying cause, so the home is continuing to move. And that's why it simply cracked again right after it was patched. Some of the patches are very wide, so I don't know if the house is somehow separating from right to left. You'd have to see the rest of this home to be sure. And I don't really know, based on the photo, what was going on here, because I don't think this is even my photo originally. But we've seen enough here to know that we're going to be recommending further review by a foundation contractor or a licensed structural engineer. And you will pick between those two based on what else you see, and based on what your gut feeling is when you're done with the inspection. If you really feel that an engineer needs to look at it, then that's who you recommend. This has been patched and it cracked again. This crack will also show up around the corner. Most likely, the foundation is moving, so recommend further review by either a foundation contractor or, if you really feel like you need it, a structural engineer. Once you move into the interior of the home and the finishes appear to be newer, and you see interior defects that appear to coincide pretty well with some of the exterior defects that you've seen, then you can be pretty confident the house is experiencing recent or even current structural movement. And you can confidently recommend further evaluation by a foundation contractor or a structural engineer. Here is some classic step cracking on a home from 1901. I doubt that it cracked recently. There has been no obvious patching done. There doesn't appear to be very much of any differential settlement or movement. And that's why I put the question mark in this photo, because just based on what you see here, there's really not much wrong. However, as you know, you should inspect the interior before deciding for sure whether this is a problem or not. When you get done with the exterior and you get into the interior of the home, you move into the dining room, and you find this diagonal crack in 6-year-old wall covering. Now, how do we know it's 6 years old? Well, first of all, the finishes do appear to be newer. But what made it sweet here for us is, during the home inspection, we overheard the current owner talking to the client. And they stated that they had just moved into the home 6 years ago, and they had everything re-wallpapered before they moved in. Awesome. Very sweet. So now I know that this cracking had to occur in the last 6 years. And the corner we looked out outside with the step cracking is just off to the left of this room, because to the left of the photo is an outside corner. That's where the cracking was. Wonderful. Now we know that this cracking occurred in the last few years. And we can very confidently recommend review because we know the foundation is moving around. As we talked about, Masonry requires a proper steel lintel to carry all that weight. And the lintel needs to be bearing on masonry at least 6 inches. Take a look right over this garage door opening. You can see that the lintel actually stops short of bearing on any brick. It's about an inch short. Now, whoever installed this is extremely irresponsible. The reason there's no cracking in the brick above is because this is on brand new construction, literally. We were doing the punch list inspection for the home buyer. A punch list inspection is where you go through and you look for, hopefully, cosmetic defects. But you're also looking for anything that's wrong. And we found a major issue right here. So, on any home inspection, if you were to see something like this, you'll recommend further evaluation by a masonry contractor. You can already see, though, if you follow the line of the lintel from left to right, you can see that the gap in the mortar is getting a little bit bigger from left to right because the lintel is already moving down a little bit. And it won't be long before the door starts to bind up in the opening. In fact, if you look very carefully at the brick right underneath the text box, you can see the brick is already starting to crack as well, right in line with the end of this lintel. A rusted lintel in an older home can damage brick and will weaken. Recommend a masonry contractor for this. Now, we talked earlier about it's probably prudent to have a conversation with your client and let them know that they really should have a masonry contractor come in and look at this. And then talk to the client about what they would plan to do if they got the job. And they need to do that before they purchase the home because they're going to end up with a patch in this area. And it's almost impossible to match this older brick. So you'd want that client to get all the information they can before deciding whether or not they want to move forward and purchase the home. And in this concrete block wall, there is either no lintel or the lintel has severely failed for some reason. So simply recommend further evaluation by a masonry contractor. And that brings us to the end of Module 8.